We will demonstrate to all interested parties a new and extremely interesting power source, which is atomic in nature and which can supply a form of electric power for entire countries for the cost of a few dollars. It's extremely economical.
So after 7 years of working with TPUs and all kinds of analog electronics in this over unity free energy arena, I've decided to put a bunch of things together. Over the last 7 years, what I've accomplished is produced numerous events of the TPUs and the explanations from some of the forefathers. And I figured it was time to put some of those objects together to make a bigger picture from the pieces of the puzzle. So in doing that, I've built the 17-inch unit and come to realize that it's an exploded view of all the other TPUs. It's all plastic, vinyl, garden edging, twin lead wire, hot glue, white plumbing. These are all hot glued in place onto this vinyl edging. It sticks wonderfully. It's a wonderful, what would you call it? It just all worked. You need something to put on there, you stick a soldering gun through it to weld it, or you apply hot glue to keep it together. It's pretty cool. So what I did physically was reproduce what we saw in all those pictures and videos. With the way I've got these tubes laid out, the problem was is once you get done winding the vertical windings, you're stuck with what's inside. From a lot of very experienced engineers and educated people, they were all clamoring to talk about the specifications of the electronics and the antennas and power, and everybody had their niche to stand their ground on. My niche was the stun gun, electrostatics. Having read what T. Townsend Brown did with high frequency, high voltage, duplicative of what Tesla had done, I felt it was the best path to follow. Least amount of paperwork, education, and training to boot. So I'm building this simple model. Figuring it out took 4 hours. I can reproduce this now in less than an hour. 17 inches. Actually, any size, really. I'm still concerned that the diameter of 17 and what it actually does with the if this antenna aspect is valid. If it's truly an antenna at a certain frequency, then the diameter is, the diameter is truly a definite parameter that needs attention. So what I did was I just said, okay, let me copy physically what he did. I built the core out of this vinyl edging, yard edging, paper taped it together the size I want, welded it with a soldering gun. Those are the holes where the wires come back out. Hot glued the rubber tubing, the plastic tubing in there. It gives the same edge as what SM had in his large TPU. I copied the center units for what I thought they would be, because one of the things he showed, when he uses these in his TPUs, they come from a speaker assembly, and you can see the plus and the minus tabs right there. He never uses those. So that led a lot of people in the wrong way. And a lot of things SM said, people followed those instructions the wrong way. And I'll explain that in a bit. I have one of these units here. It's set on top of the TPUs. I have a second one in the works. And they're incredibly easy to build too. There's nothing. Two Radio Shack spools, really. The newer spools are the same size as what SM uses. And oddly enough, he said Radio Shack many times. This comes from Radio Shack. This comes from Radio Shack. This comes from Radio Shack. The twin lead comes from Radio Shack. The rest of the plastic comes from Home Depot. This cost about 20 bucks. Not a big deal. The whole thing is 20 bucks, and it weighs about 2 pounds. So what I'll do is I'll, at this point, run down some of the things I think Steve and Mark did to try to get something across to the public that he's not allowed to talk about. Obviously, this is forbidden technology. It's a game changer on the planet. Anybody that's delved into this and read the history of the other men through the ages knows that it can wreak some havoc in your life. So, in the big unit that SM made, it was on a big plate. That gave it set the assumption that it was heavy. People moved it with their hands this way. You said, don't touch the center, don't touch the two controls, don't put any metal in it. Because when you stuck the ammeter in there, you could read a reading. So it's quite active. So there is a transmission system happening here. One of the other things he said was, he talked about you throw bullets at a car, they don't do anything. You apply enough kinetic force, or enough velocity, and you get kinetic damage on the target. He talked about cannonballs. He talked about squeezing the hose with the water model. So I decided to work with those parameters. And what I realized was something pretty phenomenal. I mean, I can hold this to myself, but there's nothing I can do with this device. There's nothing anybody can do with this device. Not that it's dangerous itself. That was another lie SM stated. He said it was very dangerous. And the reason why is because it's a game changer. The completion of this device to produce power actually then creates a huge worldwide problem with untethered robots. And at the rate artificial intelligence is moving, we really don't want to go there. Drones, unfueled drones, they'll never have to come back. This means on land, sea, and air. And you can just pack all the CPUs you want in there and have multi-processing channels doing all kinds of nifty security things. Anyway, that's a sideline. But so one of the things SM said was, well, in the demo, he holds two leads together. You see these huge white sparks. Anybody that deals with true power, it would generate that kind of sparks with those two leads that close together would electrocute you. So that's when I came up with it. It's a stun gun circuit, and it has to be because it's Tesla is the only thing going here. So I would apply Tesla stun gun circuits to everything just to see what it would do, and everything picks it up because electrostatics is not diminished by any kind of conduction intersection. Parallel, 90 degrees, any angle. The metals just pick it up. And Tesla stated that all the metal objects in his laboratory became charged. So when SM mentioned bullets and mentioned cannons, I realized he was talking about kinetic force. And in playing with the stun guns, I had made a number of suggestions and was told by him, no, do not do that. Which now I realize he really meant yes. One of them was to take a stun gun and put a 20-foot loop of superconducting stereo cable next to an airport and fire it. The FAA would have seen that. The airplanes would have seen it. It would have been quite the escapade. So by not doing that, I remained unknown by the authorities and could stay in my house and do what I needed to do. Stephen Marks also mentions the kick. They're all interrelated. Everybody thinks you have to produce the kick, and a number of bright men have. I've got the circuits to do it in many different ways. All the different ways they said do it, I've done it, and I produce these kicks. The problem was, how do you get a stream? That's not a problem. We know that when you charge up a coil and you stop it, the back EMF is larger than the amount of power going in. That's your kick. The stream comes from pulsed stun guns. That'll be your thumping and transformer action on this. So as the stun gun fires, this one's 300,000 volts. The back EMF is greater than that, which is pretty phenomenal considering it's only a 9-volt battery. There's no other way to get any kind of other power out of this thing than to go strictly for potential. And that's the road I've gone down. So what I've done is use the stun gun circuit to drive these different coils. And I've used CFLs, ignition coils, microwave transformers, things like that. And it's all high voltage related, which Stephen Mark mentions numerous times. They're all dangerous. And for that reason. So by using the stun gun, what I've realized is that the discharges are phenomenally large. And you'll notice this model is an exact replica of what SM showed on the large TPU. And what a lot of people have missed is not just the wiring, but the configuration of the wiring. They picked all this apart many, many times, and it to no avail. So I built this physical model, and then I realized, if you take this model and you cut it in half, which is what SM did to show things, he's actually gave more away than a lot of people realized. You cut this in half, and you've got all these vertical lines, which gives you an air core transformer. So any activity that you place on these lines reflects and is transmitted into these other units. Also, you can see that the center area here is compressed. When the field comes in, it compresses into this lead, okay? If you hit this with a pulsed stun gun charge, basically what you have is a cannon. And you kinetically fire these pulses into this outside guy. This outside guy is what I'm assuming. We don't know where these are connected, this center piece. It goes into the black box inside. We don't know. The two Mylar caps on the outside of the black box look exactly like the Mylar caps used in the stun gun circuit. And in the black box, he could have hid neons, little homemade spark gaps with adjustable. You can tune them this way. It's pretty cool. Close together, it's really, really light. Farther apart, it's really, really large. So I fire these vertical leads, and the whole thing picks up. It's one big antenna made up of separate heads. And to store and magnify that action, I realized that an iron core works pretty good. I don't know if it's necessary, but the idea is what everybody did talking about first course was they were already seeing basically what they've been trained is it's always a large core and a little bit of wire. No matter what you do, it's a large core, a little bit of wire, a lot of FE. And they talk about eddy currents and heating and core vibrations and things like that. And I decided that if that's a resistive storage problem, then why not manipulate it? So based upon my first build, the GK4, I did the standard transformer build model based upon one of Tesla's patents. And I used the whole loop of this stuff. Just left it in a ring and wrapped control coils around. And it was pretty nasty. It was an open-face microwave. So I said, okay, well, why don't we lower the core content? And I did. That's what this is, iron wire. And it might be steel too. I don't think it really matters. But one of the things that SN did, I have a magnet on this ruler, taped. He would do this. You would see him do this. He'd paint or swipe the all in one direction, always in one direction. And then in one of them, he actually just stuck it on there. This won't stick because I have a little bit of iron, okay? Which tells me if he's using one of these, I need more iron. And I can feed iron down between these gaps if I need to. That's next. That's one of the options I got. So, but you always see he always does the same counterclockwise direction. Then he either pockets the magnet or he places it on the unit somewhere. So this does two things. It biases the iron, it would magnetize it. Plus, as you drag this magnet across these, cutting all these lines, you're generating a charge. Now with this two set of windings here, we don't know if they're two sets, and we don't know how they're connected. Like I said, on his speaker unit that he uses, he never uses the tabs. It could have been used for charging. It could have been used for taking readings or whatever, but he never shows them. He never does anything with them in public. So what I decided was, with the two sitting there next to each other, you could sit there and fire these in tandem, back and forth, which generates a charge out to this guy feeds back to this guy, and this guy becomes a trigger for the whole unit. So you've got this toroidal loop activating itself. He also mentions a rotating magnetic field. We know, based upon what Ltpu had put in his magnetic current book, was that with a coil this way, the magnetic field goes this way. And if this was solid metal, the electrons spin forever at the speed of light. You can break it apart and the LED lights up. We've seen that. So we know that this rotating magnetic field is in there. And it moves. Inside it goes this way, outside it goes this way, this way, this way, this way, this way. So we know also that there was a bifilar pair coming out of here. There's two here. There's two here. There's bifilar wraps in each one of these. There's two runs all over the place. It's all done in pairs, except for this 3 high here. My suspicion is that by firing one way and firing one another way, the magnetic fields do this in concert, and they hit the center run inside, which gets broken, and that creates your power. That could also be the fake ground. I do not recall Stephen Mark ever mentioning a fake ground. I know that it was brought up by a number of the other follow-on people, which stands to reason. But what I gathered from that was, what he meant was, everything stays on the unit. He said, you must put all your circuitry inside. Everything stays in the unit. And I thought, basically, this unit's never grounded. And if you look at his demos, the units are never grounded. And he even stated, you ground it, you lose it. So this thing floats with a charge electrostatically. What was the other one thing? A couple other things he said was, squeezing, yeah. So you've got this, in one of the tests I did, you've got the stun gun running out here, all echoed and driven into these parallel lines. So I drove this outside guy. He said, well, if you did the magnet and he biased the inside, and then he uses this outside run as a trigger to feed all that, then basically, as this back EMF / kick happens, it squashes or controls the bias field, which then creates these cannonballs. So he's got cannonballs out here, cannonballs in there. This high velocity kinetic energy going on. He also mentioned 5 kilohertz. That's the basic standard frequency that stun guns run on. Another thing that I found out was that you can squeeze the bias in a different way. Put your bias on the outside, put your electrostatic pumping on the inside, and you could squeeze the flux from the inside out. And as we know, the field in here would be very condensed in the center from this toroidal field, very condensed in the center, and you've got a electrostatic discharge inside of that, in that core, pushing all that out. So you can squeeze and cancel the flux from the inside out. That's one of the other things that was missed through time. See if I can remember any of the others. Now we know on the large TPU, I mean, he did drive a drill and a TV. He did do light bulbs. Light bulbs is not a big deal. Light bulbs can just be excited by noise. They really don't need current flow. I mean, I've done that with my big Tesla coil, and they light up. It's no big deal. So that's not really a proof. The drill and the TV are proof. So basically what I've been doing now is running the different combinations through all of these leads, trying to find out, do I need to take away or do I need to add? This basically is a spreadsheet for the TPU, because there's a lot of manipulations you can do with it. I can change the inner runs here. I can add more to the, in between the spaces. I don't want to change the outside winding because, as we've seen on the big TPU, it is what it is. We do know what that, we can identify that correctly. One of the things I think he did was, I think he took a trash bag and he laid it on there, and that's where he got the black coating from, and then he spray painted everything black, except for his center unit. Everything else is black, except for the capacitors too. So with the center guts removed, he shot that whole thing with black, and then for some strange reason he put white goop down there. I think visually he was trying to do things to people's minds, to not have them focus on the perfection of it, but to actually look at the simplicity, magnify the simplicity of it. He did say it's really simple. And there's a new kind of induction. Well, I found that out when I first started this. It's electrostatic. This vertical leads all parallel. That's standard, you know, whatever, air core or with multi-core or metal core or whatever. That's all the same. 90 degrees is different. Stun gun will conduct in any metal, whatever the angle is. So with these leads the way they are, I'm connecting in 600 volts bias, stun gunning it, putting in CFLs through the power supply, using high voltage scope probes that are unattached to the metal in the thing. It cannot touch any metal at all. This has to totally float. At this distance here, I pick up 160 volts as I'm putting 300,000 volts through this thing. What I want to do next is to build the stun gun control circuitry, build two of them, so that I can control the frequency, and then I can have something that's open so that I can manage and modify it if I need to. Right now, it's pretty tough because things are crammed on the circuit boards, and I don't like the spark gaps in there. I would prefer to use these. This is more replaceable. The ones they use, they get burnout between them, and carbon builds up, and then the thing burns around the connections and burns the fiberglass, burns the copper leads, and then just screws it. It self-destructs. I'd like to avoid that. But with my concept, using electrostatic voltage, this little beast transmits and receives everything. And that's what I was looking for. Now all I've got to do now is run the different combinations through of voltage, frequency, and connections, how they run, to see where and how he pulled the power off. Like I say, he had two of these, two caps, two, I believe, huge diodes in there. He had two fuses on the back. They could have been a stun gun circuitry. I think they could have been the spark gaps. We never seen that. And he did mention that, you know, I busted a fuse to use those as a spark gap. I know that's pretty interesting. So cheap and easy and simple. Like you said, Radio Shack. Radio Shack, Home Depot. I've got enough parts to make another one. It'll be the third one. I've already got, what I started with was I started with a big one of just this without the outside wrapping. Exact same thing. And I put multiple strands of lamp wire, multiple runs of iron wire between them, and played with the transformer action and saw that this motion is very important. They run different directions, and the fields do this. You run them in the same direction, and the fields collide, and it's just more chaotic, and you don't get what you don't get. The high voltage on the scope dissipates really fast when they collide. When you move them together, the voltage stays longer. So this thing has a storage capability in it, which also adds to Stephen saying the ramp up. The bias ramps up, the whole thing stores this electrostatic capacitive inductance charge in here. And then when you click this thing, you can see the voltage is small, and when you let go, you get the huge voltage, and then it dims down. Boom, it ramps down. My first unit was this plastic tubing in there with just one run of lamp wire. Just in air. And I said, oh, this is a large antenna on a stun gun, and this works too. I had an 8-foot ball of energy. Boom, 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 as the spikes came through. And I thought, okay, well, I'll just graduate in graduated greater and greater steps to put together what what I've done in the past, small steps. So basically, in any kind of design process, in R&D and figuring things out, you make a bunch of small steps. You go, oh, this is what this does, and that becomes a support layer. And then you take the effects and events of that, and you go one step up, and you build the next layer, and you go, okay, up and up, and you keep going to the. It's like a rack of cue balls. 5, 4, 3, 2, boom, and you're done with the number one on the front. So that's the way I'm working this. I was hesitant about adding the other layers on because it makes things more visible. It gets closer and closer to a finished unit. And at some point, I'm sure that it's going to ring some bells and trigger some heat. That it's going to become obvious that somebody knows. But I'm following Tesla's lesson. He said, do a lot of tests. Don't build anything big. Don't touch anything. Just do a lot of tests and let it sit in your mind and build the models in your mind. And since the model was already built, I said, well, 7 years later, why don't I just do this? I'm a fan of the hardware store and Radio Shack, and yeah, it's a piece of cake. And like I said, cable ties, vinyl, soldering gun welding, hot glue pressuring, this is hot glue. I can't get that out anymore, but basically, as far as a pretty slick trick you can use is water bottles. Water bottles is the same vinyl as all this other stuff. And basically you can cut strips and make molds out of it. So what I did was I took a piece of water jug, sliced it down to what size I needed to fit this inside these things, and then I cut it edge to edge. And then what I did was I scotch taped it, put it on a panel, put the wire through it, shoved hot glue down to it, let it dry, and now this thing is just a plug that slips in and out. just to get this unit centered like what's in his unit. So I carry on. And I've got another thing you can do is take index white tag or white string tags, cut them apart, and make labels for your wires that way. Instead of using tape, you see this is number 2, but there's number 1. Instead of using tape, you can just clip these guys on and just move them around if you want, and you can always identify them. And that way, it always shows in the videos or any kind of documentation you make. It's pretty self-documenting. I'd say show a schematic, label the schematic as to these, runs with these wires, and you can pretty much see pretty clear without running a lot of stuff up. You do a schematic, you put the labels show up on the device, bingo, you're done. And then people can ask about, well, what about number 1? What about number 2? What about the center device? And pretty much focus their questions as this build progresses. I don't know how many people will copy this. It's not expensive and it's not hard to do. It's not as laborious as the other ones. You got small thing, you're putting these spools of wires through there and tightening it. Nope, this guy does all the spacing itself, and this is 100 feet. A purchase of 1 spool, and it doesn't even come with a spool. It comes wrapped up like to itself, and you just keep throwing it through there, and it lines itself up really nice. And guess what? 17 inches gives you this nice run-to-run, end-to-end, start to finish with the gap that is an Ltpu. So I pretty much physically tried to copy as much as we understood of what we could see and the information that I got from what others had done. And so this is my piece of documentation adding to all those efforts. So I would say that this is not the top ball in the Q rack. This is maybe parts second, third, fourth layer in there, but the bottom 5 balls in the rack are pretty much, there's not much more you can add. Now, if this is based on diameter, circumference, some special tuning, some special magic, highfalutin resonant antenna that, I haven't taken the time to measure or do the math on, then this won't work. But as Sam said, it's pretty simple. The other thing is this antenna is facing the earth and it's facing the sky. And as we jack this aperture, we do get a transmitting and receiving antenna that's very large compared to the physical size, and can pick up a lot of whatever happening in the ionosphere or the earth, whatever if we're doing anything to it at all. And since there is this vibration and gyroscopic, I would seriously believe that it is working with the planet. One of the original pictures I had showed was the Earth's magnetic field coming across and bending into this. Because, the Earth's field goes this way because we are perpendicular to the surface of the Earth. So as the field comes back to the North Pole, there it points into the planet. But here it's running across us like this, and it's in graduated onion skin layers. So you do get varying potential as you raise this up in the sky. So try to keep it simple, simplistic, and follow basically the easiest way out to prove whether this is as complicated as what all of the highly educated people cannot figure out, or is it this damn simple? I believe it's this simple. And so I'm going to keep pushing with this model until when anybody else suggests too. It's not really mine. I'm producing this video to make it public so that other people can get ideas from it and can see and just post combinations. I did bring over-unity calm down 3 times in 2007 with my builds and tests that I did. And so now this time I'm hooked to YouTube, and I should get a lot of hits, and it should equate to dollars and cents. And I'll post that too. It's not a big deal. There's nothing hidden here. I've never kept anything hidden. Otherwise, there's just too many damn things that just make sense. too many things that SM said that are really, really simple, that have really been taken out of context. So I thank those that have been patient with me, offered me information, guided me along, and and you're welcome to the other people that I've done the same to. One big happy family. I'm not saying this unit's finished. I'm just saying that it's a good model to prove or disprove at this point. Only weighs 2 pounds. It's quite a bit light. So I'll keep moving on, building these physical models and putting these things in front of my face to see that oh, this is an obvious thing right here. I was like, oh geez, I'm surprised nobody saw that before. One of the things I did see in the beginning was SM didn't put these in the center. He put them off because he said you don't want to tune it right on. Putting it right here puts it in the center of the TPU field, the toroid field. So he placed them off to the edge just far enough. So his tuning is physical this way. So yeah, that's pretty interesting. So I'll close this video at that, and we'll see how viral this goes.
We will demonstrate to all interested parties a new and extremely interesting power source, which is atomic in nature and which can supply a form of electric power for entire countries for the cost of a few dollars. It's extremely economical.